हेलो गाइस, दिस इज आदित्य गौरव और आप देख रहे हैं सरजी भाई फ्यूचर डॉक्टर और मैं हूं आपका सारथी इस बायोलॉजी के कोर्स में। तो दोस्तों, जैसा कि मैंने आपको बताया था कि एनिमेटेड वीडियो के थ्रू हम लोग पढ़ेंगे सारे चैप्टर को और सारे पूरे के पूरे कोर्सेज को। तो चलिए चलते हैं बायोलॉजी के तीसरे चैप्टर की तरफ, जिसमें कि ह्यूमन रिप्रोडक्टिव ऑर्गन्स के बारे में बताया गया है। तो चलिए चलते हैं एनिमेटेड वीडियो की तरफ। तो गाइस, जैसा कि हम सभी जानते हैं, ह्यूमंस जो होते हैं यूनिसेक्सुअल होते हैं और विविपेरस होते हैं। द मेजर रिप्रोडक्टिव ऑर्गन्स include external genitalia like penis in male and vulva in female, along with number of internal organs including gametes producing gonad like testes in males and ovaries in females. तो चलिए अब हम जानते हैं मेल रिप्रोडक्टिव सिस्टम के बारे में। मेल रिप्रोडक्टिव सिस्टम जो होता है पेल्विक रीजन में लोकेटेड होता है, जिसमें इंक्लूड होता है टेस्टिस, एक्सेसरी डक्ट्स, एक्सेसरी ग्लैंड्स एंड एक्सटर्नल जेनिटेलिया। Testes are situated outside the abdominal cavity within a pouch that is called scrotum. Scrotum जो होता है पेनिस और एनस के बीच में लाइज करता है। टेस्टिस जो होता है वो बॉडी टेम्परेचर से 2 या 2.5 डिग्री टेम्परेचर कम चाहिए होता है स्पर्म के प्रोडक्शन के लिए। इसी कारण से स्क्रोटम जो होता है बॉडी के आउटसाइड में होता है और इसका टेम्परेचर बॉडी टेम्परेचर से लोअर होता है। स्क्रोटम का जो टेम्परेचर होता है वो होता है 34.5 डिग्री सेल्सियस टू 35 डिग्री सेल्सियस। टेस्टिस जो है ओवल होता है शेप में। इसका जो लेंथ है वो 4 to 5 सेंटीमीटर होता है और जो इसका वेट है वह 2 to 3 सेंटीमीटर होता है। टेस्टिस जो है सराउंडेड बाय होता है टफ कनेक्टिव टिश्यू कैप्सूल से, जिसे कि हम कहते हैं ट्यूनिका एल्बोजेनिया। सभी टेस्टिस में 250 कंपार्टमेंट्स होते हैं, जिसे कि हम टेस्टिकुलर लॉब्यूल्स कहते हैं। एंड ईच लॉब्यूल्स इन टर्न कंटेन 1 to 3 हाईली क्वाइल्ड सेमिनिफेरस ट्यूब्यूल्स। सभी सेमिनिफेरस ट्यूब्यूल्स के जो लाइनिंग होते हैं उसे कहा जाता है जर्मिनल एपिथेलियम, और ये कंटेन करते हैं मेल जर्म सेल को, जिसे कि हम कहते हैं स्पर्मेटोजेनियम और सैटोली सेल्स। यू नो द मेल जर्म सेल्स अंडरगोज meiotic division for finally leading to a sperm formation, while Sertoli cells provide nutrition to the germ cell. और सेमिनिफेरस ट्यूब्यूल्स के जो आउटसाइड का रीजन होता है उसे हम कहते हैं इंटरस्टिशियल स्पेस, और ये कंटेन करते हैं स्मॉल ब्लड वेसल्स एंड इंटरस्टिशियल सेल, जिसे कि हम लीडिंग सेल भी कहते हैं। लीडिंग सेल्स सिंथेसाइज एंड सीक्रेट टेस्टिकुलर हार्मोन्स कॉल्ड एंड्रोजेंस रेटी टेस्टिस, वासा इफ्रेंसिया, एपिडिडिमिस एंड वास डिफरेंस, ये सारे जो है मेल पार्ट्स हैं एक्सेसरी डक्ट्स के। रेटी टेस्टिस जो होता है सेमिनिफेरस ट्यूब्यूल से बना हुआ होता है। वासा इफ्रेंसिया जो है सिलिएटेड डक्ट्यूल्स है, जो कि एराइज होता है रेटी टेस्टिस। यह जो है स्पर्म को कलेक्ट करता है और ट्रांसफर करता है एपिडिडिमिस में। एपिडिडिमिस जो है लॉन्ग नैरो हाईली क्वाइल्ड ट्यूब्यूल्स है, जो कि अलोंग द पोस्टीरियर सरफेस ऑफ द टेस्टिस होता है, और ये डिवाइड किया गया है 3 पार्ट्स में। वो है एंटेरियर कैपुट एपिडिडिमिस, मीडियल कॉर्पस एपिडिडिमिस एंड पोस्टेरियर कॉडा एपिडिडिमिस। एपिडिडिमिस जो है स्पर्म को स्टोर करता है टेम्पोररली और उसके बाद नैरोसेस देम। द एपिडिडिमिस लीड्स टू द वास डिफरेंस दैट सेंस इनटू द एब्डोमेन एंड कर्व अराउंड द यूरेटर टू लूप्स ओवर द यूरिनरी ब्लैडर। ये जो है बैकवर्ड एक्सटेंस करता है, डक्ट्स को रिसीव करता है सेमिनल वेसल से और फाइनली ओपन होता है यूरेथ्रा में as inoculatory ducts. The neck of urinary bladder, ejaculatory duct, and prostate gland open into the urethra or urinogenital canal. The urethra originate from the urinary bladder and extend through the penis to its external opening that is called urethral meatus. The urethra is the common passage for urine and sperm. Male accessory glands contain करते हैं seminal vessels, prostates and pair of bulbourethral glands. They secrete seminal fluid that contain fructose and prostaglandins. प्रोस्टेट ग्लैंड जो होता है यूरिनरी ब्लैडर के बेस में होता है और सेमिनल वेसल्स के बेस के अराउंड में, और ये यूरेथ्रा में जाकर के ओपन होता है थ्रू सो मेनी डक्ट्स। और जो प्रोस्टेटिक फ्लूइड होता है वो कंटेन करता है कैल्शियम, साइट्रेट और फॉस्फेट आयंस। बल्बोरेथ्रल ग्लैंड जो होता है वो एक पी साइड स्ट्रक्चर होता है जो कि पोस्टेरियर ऑफ द प्रोस्टेट ग्लैंड और पेनिस के बेस पे होता है, और ये जो सीक्रेट करता है जिससे पेनिस के लुब्रिकेशन में हेल्प होता है। मेल का जो एक्सटर्नल जेनेटेलिया होता है उसे कहा जाता है पेनिस। पेनिस जो है कॉपुलेटरी ऑर्गन है और ये कवर्ड होता है लूज स्किन से। द स्किन दैट हैंग ओवर द टिप ऑफ द पेनिस इज नोन एज द पीपस फोर स्किन। इट इज मेड अप ऑफ द स्पेशल टिश्यूज लाइक corpora cavernosa, corpus spongiosum. The tip of the penis, covered by the capus, is called the glans penis. The penis, urethra, vas deferens, and corpus glands together help in copulation and the deposition of sperm in the female. Now in the female reproductive system, including ovaries, oviducts, uterus, cervix, vagina, and the external genitalia located in the pelvic region, along with the pair of mammary glands, female reproductive system supports the process of ovulation, fertilization, pregnancy, and childbirth and child care. चलिए अब पढ़ते हैं सभी ऑर्गन्स के बारे में डिटेल में। फीमेल रिप्रोडक्टिव सिस्टम जिसमें कि पेयर ऑफ ओवरीज होते हैं, ये लोकेटेड होते हैं लोअर एब्डोमेन के दोनों साइड। ये जो है प्राइमरी सेक्स ऑर्गन्स होते हैं जो कि प्रोड्यूस करते हैं ओवम फीमेल गैमेट्स के लिए। सभी ओवरीज 2 से 4 सेंटीमीटर लंबा होते हैं और ये कनेक्टेड होते हैं पेल्विक वॉल और यूट्रस से हेल्प ऑफ द लिगामेंट कॉल्ड मेसोवेरियम। सभी ओवरी कवर्ड होते हैं आउटर थिन लेयर से जिसे कि हम कहते हैं जर्मिनल एपिथेलियम। जर्मन एपिथेलियम encloses the ovarian stroma, which is further divided in the outer cortex and the inner medulla. The cortex consists of many ovarian follicles in different stages of development. Ovarian follicle जो है बेसिक यूनिट है फीमेल रिप्रोडक्टिव सिस्टम का and is composed of roughly aggregation of cells जो कि ओवरी में पाए जाते हैं। एसेसरी डक्ट्स जो कि फीमेल रिप्रोडक्टिव सिस्टम के है वो है वेजाइना, oviducts and uterus. The pair of oviducts of the fallopian tubes is about 10 to 12 centimeter long and extend from the periphery of the each ovary to the uterus. सभी ओविडक्ट डिफरेंशिएट किए गए हैं 3 पार्ट्स में, जिसे कि हम इन नामों से जानते हैं: इनफंडिबुलम, एम्पुला और isthmus. The infundibulum is the dilated funnel close to the ovary, and its edges are surrounded by the finger-like projections called fimbriae. They help in the collect and push the ovum after ovulation. The ampulla is the swollen and curved part behind the infundibulum. The fertilization of the ovum takes place in this part. The isthmus is the narrow, straight cavity and it joins the uterus. The uterus is the hollow, pear-shaped muscular organs and highly distensible, and uterus is situated in the pelvic cavity between the urinary bladder and rectum. It is also known as the womb. It is supported by the ligament and attached to the pelvic wall known as mesometrium. The uterus opens into the vagina through the narrow cervix, and the cavity of the cervix is called cervical canal, which along with the vagina and forms the birth canal. The wall of uterus is composed of 3 layers of tissues. The outer thin membranous layer is called the perimetrium. The middle layer, which is thick, is called myometrium, and it helps during delivery by producing a strong contraction motion. The inner glandular layer is called the endometrium, and it undergoes cyclic change during menstrual cycle. The vagina is the muscular tube starting from the lower end of the uterus up to the outside. The opening of the vagina in young female partially covered by the thin membrane called hymen. Hymen is frequently ruptured during childhood due to physical exercise. The female external genitalia includes the mons pubis, labia majora, labia minora, clitoris. The labia majora consists of fleshy folds of tissues that extends down from the mons pubis and surround the vaginal openings. Hidden under the labia majora is the labia minora. Towards its upper end lies the clitoris. It is a small finger-like structure, and below it, urethral opening. The female reproductive system is supported by the mammary glands. The mammary gland and breast are modified sweat glands that lies over the pectoral muscles. They contain glandular tissues and a variable amount of the fat. Internally, each breast is divided into the 15 to 20 mammary lobes and containing clusters of cells called alveoli. The alveoli open into the mammary tubules. The tubules of each lobes joins to form mammary duct. Several ducts joins to form the ampulla, which is connected to the lactiferous duct. The lactiferous ducts open out through the nipple, from which the milk is sucked out. There are 3 phases in the life of the living organism, that is juvenile, reproductive and senescent. During the reproductive phase, organism birth his offspring. रिप्रोडक्टिव फेज के दौरान मोस्ट ऑफ द ऑर्गेनिज्म में फिजियोलॉजिकल और मॉर्फोलॉजिकल चेंज देखने को मिलता है. ह्यूमन फीमेल फॉर इंस्टेंस experience the menstrual cycle, which is defined as the cyclical changes in the genetical system during the reproductive phase. Incidentally, woman experiences her first menstrual cycle, called the menarche, at the onset of puberty, usually between the ages of 9 and 12, occurring approximately every 28 days. A single menstrual cycle consists of 4 phases: menstrual phase, follicular phase, ovulatory phase, and lastly, luteal and purgatory phase. Each phase of menstrual cycle are marked by the simultaneous changes in the uterus, ovary, and the secretion of hormones. For instance, during the menstrual phase, The endometrial lining of the uterus and its blood vessels break down and make sweat bloods, mucus, and other cell debris to form menses. The menses are discharged through the vagina as menstruation of menstrual flow, which lasts to 3 to 5 days from the beginning of the menstrual cycle. जैसा कि आप सभी जानते हैं, the absence of menstrual cycle it indicate pregnancy and ovarian disorders such as polycystic ovarian disorder or stress. The menstrual phase is followed by the follicular phase, which occurs between the days 6 to 14 of the menstrual cycle. During this phase, the primary follicle in the ovaries matured into the Graafian follicle. Simultaneously, the endometrium undergoes proliferation, the process of regeneration which results in the formation of the new, thick endometrium. Now, the follicular phase followed by the ovulatory phase, which occurs during each menstrual cycle. During this phase, the Graafian follicle ruptured to release the ovum or egg cell into the pelvic cavity. That process is called ovulation. Now the ovulatory phase is succeeded by the luteal phase. Luteal phase is the last phase of the menstrual cycle, which occurs between the days 16 to 28 of the menstrual cycle. This phase sees the transformation of the remaining Graafian follicle into a yellow marks called corpus luteum. The endometrium too thickens, its blood vessels become coiled and also enlarged. Now the endometrium and corpus luteum play a very vital role during the early stages of conceptions. For instance, the fertilized egg gets embedded in the endometrium and derives nourishment from it. The corpus luteum, on the other hand, starts the secreting progesterone, and that helps to maintain the endometrium and encourage the growth of the developing embryo. Conversely, in the absence of fertilization, corpus luteum is generated and triggers the breakdown of the endometrial sheathing. This marks the start of the menstruation and the beginning of the new menstruation cycle. The phases of the menstruation cycle are controlled by the interplay of the different hormones secreted by the ovary and the pituitary gland. At the onset of menses, anterior pituitary gland increases the secretion of the two gonadal tropical hormones, luteinizing hormones LH and follicle stimulating hormones or FSH that stimulate the development of follicle. However, the amount of estrogen and progesterone released by the ovary during this time is less, and it causes the thinning of endometrium. The release of LH and FSH keeps increasing, and during the follicular stages, these two hormones stimulates the maturations of the primary follicles to the Graafian follicle. LH and FSH stimulates the maturing follicles to release estrogen, the hormones that helps in the proliferations on the endometrium. The increased level of estrogens in turn cause the interior pituitary gland releases surges LH and FSH. So much so, on the ovulation stage, the level of LH and FSH in the blood are on the peak. This LH size causes ovulation, rupture the Graafian follicle, and turning the follicle remnants to the corpus luteum. Estrogen level in the body is 2, reaches on the peak. However, once the corpus luteum begins secreting the large number of progesterone and FSH and LH inhibiting hormones, the level of both these hormones drop, which in turn also the level of lower estrogen in the body. Incidentally, the corpus luteum keeps secreting progesterone if the fertilized egg gets embedded in the endometrium. In the absence of fertilized egg, the corpus luteum stops releasing progesterone and regenerates, but drop in the level of estrogen in turn trigger menstruation as well as the restart of LH and FSH by the pituitary gland. Menstrual cycle stops when woman reaches its 50 age. This phase is called menopause. The menstrual cycle is an important process in the female body and it consists of 4 phases which are controlled by the hormones released by the ovary and the pituitary gland. Now, fertilization of fuses of gametes is the very most vital event in the process of sexual reproduction, as it results new life. In human, the male gamete's sperm is motile, female gamete ovum is non-motile. Therefore, the fertilization occurs, both gametes fuses together. This is achieved through insemination. The penis releases semen filled with thousands of sperm into the vagina, and while half of the total sperm released carry with X chromosome and other half contain Y chromosome. These sperms rapidly move through the cervix and pass through the uterus and finally reach the ampullary isthmic junction of the fallopian tube. Till the same time, the ovum, after completing the first meiotic division, gets released into the fallopian tube with the rupture of Graafian follicle. Upon its release, the ovum begins to undergo the second meiotic division. However, the division does not go beyond the first phase, and the ovum only contains the X chromosome. Studies have shown the ovum has contained cytoplasm called the vitellus, and it is surrounded by the membrane called vitelline membrane. Vitelline membrane is enclosed with the other membrane called zona pellucida. However, there are some space between the zona pellucida and vitelline membrane is called perivitelline space. Surrounded the zona pellucida, there is a layer of granulosa cells called corona radiata. The ovum present in the fallopian tube now start drifting toward the uterus. Once it reaches the pituitary estrogen junction, ovum gets bombarded by the sperm. However, only one sperm penetrates the zona pellucida and now initiate the fertilization process. Moreover, this penetrating sperm induces the zona pellucida to stiffen, which prevents the other sperm to entering the ovum. After gaining entry through the zona pellucida, the acrosome present over the squamous nucleus start secreting enzymes that aids the sperm head through the ovum cytoplasm. The sperm sets its tail. The fertilized egg now resumes the remaining phases of the second meiosis division. However, this division being unequal results in the formation of two unequal bodies. haploid ovum called otid, and second polar body. While the second polar body degenerated, the otid and the diploid generated nucleus. The sperm fuse together and form zygote. You know the sex of zygote is decided at the time of fertilization. If the ovum is fertilized by the sperm which containing the X chromosome, resulting zygote containing double X develop into the female. If a sperm contain Y chromosome, then it develop into the XY, and it means the baby is male. Thus, it is the sperm that decide the sex of the fetus. A little more the day after its formation, the zygote start moving down the fallopian tube. Simultaneously, the zygote also undergoes mitotic division, and each successful mitotic division, number of daughter cells doubles. This division is termed as cleavage, while the resultant daughter cells are called blastomers. About 3 days after the fertilization, the zygote containing 8 to 16 cells, that is called morula. The period of 2 days, morula descend down to the uterus and transform itself into the blastocyst. A hollow ball composed of about 100 of blastocysts arranged in 2 layers. The ultra layer, called the trophoblast, eventually gives rise to the placenta. The inner layer, called inner cell mass, eventually differentiate to form the embryo. At the blastocyst stage, the zygote, which now called the embryo, is attached to the uterus as the trophoblast closed outwards and penetrate the endometrial lining of the uterus. In response, the endometrial cells divide and start surrounding the blastocysts. This causes the blastocysts get sink and planted into the uterus. Once implantation is occurs, pregnancy gets initiated. Moreover, after implantation, the inner mass cells get differentiated and begin to form the embryo. Embryo formation is thus a complex formation, begins with fertilization and ends with implantation of the embryo. The joys of holding the newborn baby know no bounds. Birth of a baby is an intricate and very complex process that begins from when the zygote goes cleavage and develops into a blastocyst, hollow ball consisting of a trophoblast and inner cell mass and cavity called blastocoel. As the trophoblast goes outwards and penetrates the endometrial lining of the uterus, the blastocyst with the developing embryo gets planted in the uterus and pregnancy is initiated. After implantation, the trophoblast goes further, which causes the blastocells sinked, get covered by the cells of the uterus. The blastocell sinks further into the uterus. The finger-like projections called chorionic villi started pairing trophoblasts. As the chorionic villi go further, interlock of uterine tissues to form the placenta, a structural and functional unit between the developing embryo and maternal body. When the placenta begins to form, inner cell mass moves down and differentiate, form an embryonic disc which consists of 3 germ layers: the outer ectoderm, the middle mesoderm, and the inner endoderm. The term germ layer indicates that each of the layer gives rise to tissues. Ectoderm, for instance, get rise to the nervous system and the skin, whereas the mesoderm develops into the muscles and organs such as the heart and kidneys, while the endoderm gets rich into the entire digestive systems. Did you know that apart from the three germ layers, the embryonic disc also certain cells called stem cells, which has the ability to give rise all the tissues and present organ in the human bodies. Now as the embryonic disc grows, the cells of the one side of disc grows faster from the other sides. This causes the disc roll and cylindrical embryo. Initially, this embryo is attached to the placenta, but as it starts to develop, it moves away from the placenta and remains connected to it by an umbilical cord. The placenta is an important structure, supply the embryo with oxygens, nutrients and also hormones, as well as carry waste product from embryo back to the mother. The embryo stays inside the mother to 9 months, which is called the gestation period. During this period, the embryo undergoes several developments. By the end of the first month, embryo develops the heart. At the end of the second month, embryo marks the transition embryo to a fetus, developing fetal limb and digits. And now by the end of the third month, most of the organs are already formed. And now on the another 4 months, the fetus is rapidly gaining weight and now its bone gets very stronger. Now by the beginning of the 9th month, the fetus is fully developed and it assumes the position it will get during the delivery. While the fetus undergoes several developments, changes, the mother body is too undergoing several hormonal changes. The ovary, for example, starts secreting the hormones called relaxin. Likewise, the placenta starts secreting hormones called human chorionic gonadotropin and human placental lactogen. Incidentally, HCG, HPL, and relaxin released when woman gets pregnant. Apart from the secretion of these hormones, the level of other hormones such as estrogen, progesterone, and cortisol, prolactin, and thyroxine also rise rapidly in a pregnant woman's body. These hormones support the growth of the fetus as well as maintain the pregnancy. Increased level of progesterone and estrogen, for instance, put the menstrual cycle on hold, prevent the shedding of the uterus lining, which is embedded with the developing fetus. Hormonal changes also cause the cells of the mother mammary glands differentiate, resulting in these glands producing milk by a process called lactation. What's the end of pregnancy? Did you know the end of the period of gestation? The fetus as well as the placenta start the secreting hormones that set in the motion in the contact, the fetal ejection reflection. These contractions in turn act on the mother of the pituitary gland that now starts secreting oxytocin, the hormone that causes stronger equity in contraction. The simultaneously in contraction, oxytocin release and make the contraction stronger, and every passing minutes ultimately results in the expulsion of the baby from the mother uterus. This process of delivery of the fetus is called pasteurization. Immediately after the birth of the baby, placenta is expelled from the uterus. Soon after the birth, baby needs to be breastfed by the mother as soon as possible. This is because immediately after maturation, mammary glands start secreting colostrum, the form of milk that is rich in the antibodies, also improve the immune system of the baby. Everybody begins its journey thus as a zygote, which develops into a fetus over 9 months. Reproduction, an important process in human body, involves in the fusion of the sperm and ovum, which is known as the male and female gamete. These gametes are formed by the process called gametogenesis. In males, the process of gametogenesis occurs in the testes and is called spermatogenesis, whereas in female, the spermatogenesis is called oogenesis and occurs in ovary. Spermatogenesis and oogenesis begins in different ages. Spermatogenesis begins at puberty, usually between 12 and 13 years of the age, and it is divided into the two stages, spermatocytogenesis and spermiogenesis. Spermatocytogenesis is the first stage, occurs in the seminiferous tubules, whose inner walls was lined with spermatogonia, the diploid male germ cells containing 46 chromosomes. Some of these spermatogonia divides mitotically to form two daughter cells. For these two daughter cells, one remains the spermatogonium, while the other one called the primary spermatocyte. These primary spermatocytes divide mitotics to form two equal cells, and these are called secondary spermatocytes. Like primary spermatocytes, secondary spermatocytes are haploid cells and containing 23 chromosomes in each. Spermatocytogenesis is succeeded by spermiogenesis, during which the spermatids differentiate into an elongated for life sperm called spermatozoa or sperms. However, during this process, the heads of the sperm remain embedded into the Sertoli cells, which provide the developing sperms with nutrition. Post spermatogenesis, non-motile sperms are released into the lumen of seminiferous tubule by a process called spermination. Lumen has testicular fluid transport the non-motile sperm to the epididymis, where they mature, now become motile. During ejaculation, sperm from the epididymis transported via the vas deferens to the urethra in the penis. As the sperm passes through the different tubes, mixes with fluids secreted by the seminal vessel and prostate glands to form a mixture called semen, which is ejaculated by the penis. Did you know that semen released during the single ejaculation contained 200 to 300 millions of sperm? Microscopic studies has revealed that the typical sperm covered by a plasma membrane and has 4 distinct parts: head, neck, middle piece and tail. Inside the head is elongated haploid nucleus containing chromosomes. The anterior part of this nucleus is acrosome. It is the cap-like structure help to fertile ovum. Sperm head is followed by its neck and neck is followed by its middle piece. And middle piece is filled with mitochondria. These mitochondria break down the glucose of the semen to produce ATP, an energy molecule that power the movements of the sperm tail. The formation of the sperm is triggered when the hypothalamus secretes high level of gonadal troubles releasing hormones or GnRH. GnRH, actually the anterior pituitary gland, and stimulate the secretion of the luteinizing hormone or LH and follicle stimulating hormone that is called FSH. LH turn stimulates the leading cell to synthesize the androgen hormone that trigger spermatogenesis. FSH on the other hand acts on the Sertoli cells, stimulate the sequence of substances that enter sperm cells during spermatogenesis. While spermatogenesis occurs at puberty, oogenesis is triggered before the woman's birth. When the germ of epithelial cells in the ovary of the fetus divide mitotically to form gamete mother cells called oogonia, the few oogonia divide again to form two immature cells called primary oocytes. The primary oocytes when get enveloped by a layer of squamous granulation cells and together they make a primordial follicle. The oocyte further develop and as the fetus develop, but the granulosa cells not change till puberty. Primary oocytes enter the prophase, meiotic division remains stunted till puberty. Did you know that at birth the female has approximately 7 lakhs oocytes? Incidentally, no oocytes are formed after birth, but by puberty, most of the primary oocyte generates, leaving only about 4 lakh primary oocytes in the ovary. At puberty, the release of LH and FSH hormones stimulate some primary oocytes to resume meiotic divisions that have been done during the woman's growth stage. Moreover, due to FSH, the squamous cell of the primordial follicle enlarged and become cuboidal. The dividing primary oocyte and granulosa cells now make up the primary follicle. The primary follicle is transformed into a secondary follicle when it enlarges and surrounded by the cellular layer of granulosa cells, which in turn are enveloped by a developing theca or capsule. Later, these granulosa cells secrete estrogen, which creates the antrum, fluid-filled cavity among the granulosa cells. Moreover, the theca becomes evident and gets organized into the two layers, theca interna and externa. This structure is now called tertiary follicle, as the secondary follicle transforms itself into a tertiary follicle. The primary oocytes within the follicle contain meiotic division complete, which is an unequal and use a large secondary oocytes and a tiny first polar body. Polar body is believed to degenerate, leaving the tertiary follicle only the secondary oocytes ovum. As the tertiary follicle develop into a mature follicle, Graafian follicle, the antrum grows and the secondary oocyte and surrounding granulosa cells are pushed towards one end of the follicle. The granulosa of the cells secrete a glycoprotein substance that forms the membrane, the zona pellucida. around the secondary oocytes. The secondary oocytes of ovum is released from the Graafian follicle when it ruptured due to a surge in LH in the body. This process, ovulation, causes the oocyte of the ovum to be placed in the oviduct, where it waits the fertilization by a sperm. Now, in this way, the ovum and sperms are formed through a long great process that is called gametogenesis.